Yeah. Yeah, we're gonna get started. Thanks everyone for coming out and helping us celebrate World Water Day. That was yesterday, but our club is very heavily focused on water resources, and so we thought it was great for us to present today. Yeah, we're partnering with the Water Resource Institute, and we're just gonna talk a little bit about our club and then hear from an alumni who had a pretty big impact on our club. So to start with some introductions, my name is Josie. I serve as the Vice President for Engineers Without Borders. I'm a senior environmental engineering major with plans to attend Vancouver University of British Columbia in the fall for grad school.
Hi, my name is Garrett. I'm the outreach liaison and one of the design leads on the international project. I'm a senior as well in environmental engineering, and I will be I'm moving to New York City to work for Hazen & Sawyer doing water and wastewater treatment next year.
Hello, everybody. My name is Sienna. I'm the International Project Manager, and I am a senior in mechanical engineering. Been involved with this club for 4 years, and I'm really excited to share with you all what we've got today. Yeah, yes, fantastic. Okay, cool.
Okay, great. So a little bit about what we'll be talking today, just on our introductions. We'll touch on what Engineers Without Borders is for those that are not familiar. I know we have a lot of our club members here today, but it's just a good refresher anyway. We'll dive into then our current projects. We have a few different ones going on through our club, which is really, really awesome and something we're super proud of. And then we're going to take a deeper dive into our international project in Kijinye, Rwanda, and just touch on the different non-engineering and technical sides of things that the project encompasses. Okay, so what is EWB, you might be asking? Engineers Without Borders, we at EWB USA, we are a cross-country international organization that works to build a better world through projects that empower communities to meet their basic human needs. So that's things like water resources, certain infrastructures, really just helping communities get engineered solutions that they can't do themselves. So here are a few different projects that we have, or just pictures of us conducting our project in the Catskills, New York, and then we also like to do local work around Vermont to help restore Vermont to what it used to be. We also do a lot more than just engineering. Like I said, we have local volunteer work. We do a lot of hands-on workshops and team-based projects. We are a big collaborative club, so we like to do just a lot of team building in general. Like it says here, one big friend group, and then we also try to do a lot of professional outreach and networking with guest lectures and mentorship opportunities.
So we are divided into a couple different project teams. We have our domestic stormwater project, which is in the Catskills in New York. We also have our local stormwater volunteering headed by our local leader, Luke. We also have our international water distribution project, which is where the majority of our funding and a lot of our club resources and kind of the basis of our club comes from. And then we also have our fundraising team who supports all of these different endeavors, ensuring that we can travel to Rwanda and that we have the money to support all of the different things we're doing throughout the community. So just as a little background on the things that aren't our international project, we have a project with CE Corps, which is our domestic project in the Catskills. We're currently on actually one of the only remaining CE Corps projects in the country, which is initial. Not sure now. All right, so Lauren and her team are working on delivering an engineering design to help a rural Catskills school with stormwater management. So they've been having a lot of problems with flooding, and this is kind of just a preliminary picture and design of what they've got going on and the designs they're hoping to implement at this school. And then this is their team. They've done a site visit, and they're currently working on delivering this engineering plan to the school so that they can then build the project. And then locally, our local volunteer work kind of started out with us working with Rebuilding Together, which is a Burlington group that we would go out a couple times a year and kind of work on other people's houses. And then last year, it started tailoring towards, we started working with FEMA and local long-term recovery groups to deal with some flood recovery issues in Vermont after some of those devastating floods that's happened over the past few years. And that kind of morphed us into doing a lot more out in the community, like with notably like mucking out people's barns and redoing mountain biking trails and just kind of stepping out a little bit more into our community to help with problems that we were seeing in Burlington. And then now that's even morphed into us partnering with Middlebury to deliver a stormwater design project. So our local team is working with the town to develop like a bioretention pond for the town of Middlebury. So it's all been kind of growing the past couple of years as we've noticed the need in our community more and more.
Okay, I'd like to introduce you all our international project. International project holds a lot of weight in our club right now. It's a super big endeavor for our club. So the way that EWB works is it's a national organization that works with student chapters like ours and helps support us in projects like this that impacts a different community. So the way our project team works is we're meeting every week, and right now we're in our design phase, and we've got like a week and a half left on our deadline to finish up our design. So it's a super exciting time for us. We've never had a successful international project this scale before, so it's a huge learning curve for us. But our meetings always like there's a lot of design work happening, but there's a lot more to engineering than just design, right? So we're doing a lot of cultural education. I'm sure most of you are familiar with the Rwandan genocide. That's a huge part of our community, and being in an international setting, you're not just there as an engineer, right? You're there as a person. And so in our club, we have this really awesome opportunity where we get to work with each other to learn as much as we can about the community that we're impacting. So along with the cultural education and design work, we're doing a lot of Kitas here on our fundraising team. We're raising crazy amounts of money to be part of this project, and a lot of work going into that. Part of EWB in different countries is working with an NGO. Our NGO right now is IDA Rwanda, and they are fantastic. It's almost like a engineering tour group, right? Like they're there to help us. You know, this is where you're going to be staying when you're in the country, and hey, the people that you're staying with, like we also know them, and they're going to get you a driver to go to your community. So it's like they cover all the aspects of everything that we need. It's a really awesome opportunity for us to learn to work with an engineer in a different company. But yeah, next slide, please. So going into our international project, like we mentioned, it's a water distribution project. So the community reached out, I think it was 2022, it was a couple of years ago, and they asked EWB, hey, this is our problem, and we'd love to be paired with somebody, right? And we were lucky enough to be the people paired with them. So the community, about a bit over 6,000, serving a school. You can see all the way down here on the bottom of our map, that is our school. School ranges from everywhere from like primary, like kindergarten, super small kids, to high school, and about 18 is where they cap off at school. Similar to our school systems, right? And so the need for this project is this community doesn't have potable water, right? This is the picture of the pipe that feeds the entire community, draining into the road, right? Like there's no chlorination, there's no treatment, there's no discussion of treatment, right? You drink the stream water and the kids are getting sick, right? There's no hand washing, there's no access to it. We were able to travel in May for our assessment phase. As part of EWBs, you travel 3 times for a successful project assessment, where you're learning to work with the community and take your surveying, going out, getting all the information you need. Then you do your design back at home, and then you go for your implementation, which is hopefully going to be December 2026. And then after that, you have your review process. But that's where we are right now with our overview. Garrett, you want to talk more?
Yeah, so to kind of dive a little bit deeper into what that means technically, kind of the first step of this is going to be developing the natural spring eye. So a big part of that is making sure that we're providing a clear source directly into our pipe system. So as you dig out that spring eye and you expose it a little bit more, you can control the flow of that water into our head tank, which is where our chlorination is going to happen. And then there will be 2 pipelines, one that's serving mainly the community down to a tap stand place so that members of the community can access it. And then there's going to be a pipe that flows down to a tank that's going to be at the school so that the kitchen and the school taps can be directly fed from there. And this kind of provides more of an ease for the school to be able to close that tank, that valve, right at where the school is. And we've made these decisions because one of the biggest parts about EWB is ensuring that our design is meeting like the community needs. So working with the community so that they adopt this design rather than letting it just kind of go to waste. And we need to make sure that the community is buying in, which is why community impact is like one of the bigger parts of this project.
Yeah, so to touch on some of the like non-technical side of things, like Jared mentioned, we want to really consider how this design, it's completely new water distribution and disinfection system. We might not think that that would have a big impact on a community, but for a community like Virginia, they've never had a system like this before. So we want to make sure that we're considering the sustainability of the project and ensure that 20 years from now, the system is still working, still distributing water, still disinfecting the water. So that requires a lot of outreach and negotiation with the community we're working with. We work to set up something called the water committee to ensure that within the community, there are members that can operate and manage and help repair the system if something happens. And a big part of that too is ensuring that there's women involved in that process. And so that's where we see a lot of potential for our club to expand to other majors other than just engineering. And we see the need for global relations majors and gender women's studies majors, because while we could easily try to conceive of a plan of how like the historical context of trying to create something like this, or thinking what we might think is best, we wouldn't ask a like gender women's studies major to design the tank system, just like we probably shouldn't try to focus on the community relation ourselves. So we really want to expand to other majors that have studied this for 3-4 years. Global relations is a good one, and just make sure that we're considering all aspects that an engineer might not hit initially as we just think about the technical side of things.
So getting into the hygiene, both my parents are in healthcare, and my entire life, honestly, that shapes a lot of it. So going to this community and being part of their home for a week and a half, it's really crazy to go. Like, how many times a day do you all fill up your water bottle and there's not even the slightest thought of how clean that water is? Oh, I drink like maybe a liter and a half, walk my feathers here, yeah, don't even consider it. But these students, I was lucky enough, I had a half day there and I got to just walk around and see what their school is like, right? There's no water for the students to wash their hands after using bathrooms. And this is what their bathrooms look like, right? It's a pit latrine, right? It's a communal building where half is for the girls, half is for the boys, like little squatty potty essentially. And no toilet paper, you're not washing your hands afterwards, and then you're gonna go eat lunch. The students are getting sick and they're saying it's only from drinking water, right? That's not just drinking water. Another part of it that was brought up was what the school referred to as the women's room, the girls' room. And what do you do when you're 13 years old and as a girl and you get your period for the first time, you don't have a way to wash your hands, you don't have a way to clean yourself off. We were really privileged that we got to speak and interview some of the students, and I'm sure you all are thinking about, like, that's not something that's easy and comfortable to talk about, the women's room, the girls' room, right? It's not a discussion that we openly have here in the US. And in these interviews, there was, I think she was about 12 years old, this girl. And we're like, oh, like, what do you guys want to talk about? Like, you know, like breaking the ice, like what are you interested to ask us questions about? And the girl was like, what are you going to do about the girls' room? Like, what's going to happen, right? It was this huge idea that we didn't come to this community thinking that we'd have the chance to aid the girls' room, right? We're just, oh, we're going to bring clean drinking water. It's huge. It's something we're working with the PAD project. We're working to get sustainable, reusable paths to this community and develop that connection separate of our club, so that when we're not going, you know, to implement, there's still the connection of this community isn't somebody dropped. They have that ability. But hygiene is going to be really big, and it's going to be really exciting to see, like, how is our impact going to change, right? Like, we're coming to bring the ability to have drinking water in this community, but the students will be able to wash their hands, right? They're going to have filtered water, and they're going to have a system that's going to support them beyond our initial idea. That's something I was really excited to be like, to call mom and dad and be like, hey guys, you're gonna be really proud of what I found today. Like, it's gonna be so cool. That's about what our presentation is right now. I wanted to start with talking about our lovely Jared Ardman here. We mentioned we got this project a couple of years ago, and Jared was in my position at that time. He was international project manager, and he did all the crazy EWB pain in the butt paperwork to get us this project. But it's been really exciting to, like, you know, we see Jared every now and then. He's helping out sometimes with the project and be able to share, like, hey, we're all here together today. But Jared?
Yeah, thanks so much. Oh,
Yeah.
great. You guys are
Yeah.
incorporated. I have to bring up the laptop. That was awesome to hear. I didn't hear the summary in a while of the whole project, and you guys have really taken it and run with it, so it's super exciting to see. So to give context on the next part of the presentation, I was asked to do a kind of like student to work-life transition presentation, and then I'm gonna give some examples about things in the water resource realm that I've been working on since I started. And I'll also talk a little bit about my own time in EWB. So a little bit of background on myself. Originally from New Hope, Pennsylvania. It's a little town like an hour north of Philly, up on the Delaware. I graduated 2 years ago now, in environmental engineering, and now I'm a water resource engineer at Stone. Then we're down in Montpelier. On the weekends, you can find me on climbing, skiing, backpacking, just doing what I can to hide in the mountains. So if you asked me before I got to UVM, I probably could have had two very different answers about what I wanted to do. It would have been either maybe like public policy or something in that realm, or professional practice, both with the kind of amorphous thought of the environment. I wanted to do something there. I wouldn't have had a better definition back then than that. Went down the engineering route, which I think worked very well for my brain. But it kind of wasn't until junior, senior year, when you get to explore your electives a bit more, that I got to look into what that was going to mean for myself. I really enjoyed classes like hydrology and groundwater hydrology courses that I'm getting some bobbleheads. Looks like some of you guys are in right now. Renewable energy courses, like a geoenergy course right there in the corner is a geoelectric plant, I think in Iceland, and studying things like that were maybe tangential to my studies initially, but were interesting to hear about. And one of my favorite classes actually ended up being about resource recovery. It was landfills, recycling, anaerobic digestion. You guys all love that, you know what I'm talking about. And then kind of expanding on trying to find my niche was like interning and trying to find out like what my calling might have been or what was really not for me. For me, it led towards the, oh yeah, I don't want to do that. It was kind of, I did an internship with a local civil and structural firm. It's a great firm. I had a really great experience with them in the summer before my junior year, but it was maybe a lot of like land development and things I wasn't quite as interested in. But I did get to refresh a lot of like the hard skills using CAD and total station survey. And I think that was a great opportunity. And I encourage anyone who's maybe in their sophomore year or something right now to think about that. And even if you don't land something that's like you want to work in your whole life, it can be very helpful to just kind of get into the motion of working and find some new skills. Like I said, I was part of Engineers Without Borders when I was here at UVM as well. At the time, we had an international project in Arusha, Tanzania. This was not officially through EWB. This was through our mentor at the time. They had some previous projects at this orphanage as well. And it was essentially a DC photovoltaic solar lighting system to light up the girls' dormitory for safety at night, and also for the eldest age group classrooms so that they could study for their high school entrance exams, which are pretty competitive in Tanzania. And we also got to visit this beautifully designed Architects Without Borders orphanage that by itself as a building case study. It produced its own biogas from livestock that they had on site. They had a giant cistern to collect rainwater so they could get through the dry seasons. They had shade crops that were watered by gray water. It was just a very cool experience to get and visit this and get some inspiration. But part of our goal that kind of morphs into how we got to Rwanda was that we wanted to reintegrate with the EWB USA General chapter. And so the first step to that was going out to the national conference in Reno, Nevada, which some people in this room went to, which was exciting to get to meet a bunch of other chapters from around the country and kind of see what it would be like to expand our own operation and move into Rwanda, which all of us heard about and are actively working on. So now I'll get into a little bit of like what that transition period was like for me from student life to professional, maybe some of the rougher sections, some of the smoother things. for you all to hear from. The first thing was my second semester of senior year. I took the FE exam. People know what that is. Is it mostly like civil environmental in the room? We have people mechanical, electrical. Yeah, okay. I'll say I don't know as much for the mechanical, electrical, biomedical side of things. How important it is, I would probably talk to other folks in your major and professors and stuff. It's more important, you're saying? Yeah, it is. Okay, gotcha. All right, so great. You're on it too, but I would say that, yeah, it's definitely helpful. Not only what helps let employers know that you're on that professional engineering track. It can be a checkbox for them to know that you're serious, and that also you've gotten out of the way. It really leaves your brain quickly, a lot of this stuff. So I kind of try to treat it like a course while still in school to study for it, and just get that out of the way. And if you need the time, also it allows you to take it maybe over that summer if you need to take it another time or two. And then that kind of gets into the applications and interview section. I'm sure a lot of you either in that process right now for internships over the summer or for full-time jobs, or maybe you have interviews for grad school, which would be a little bit different, but I think it can, the biggest thing I took away from it is just trying to get repetition, just trying to do it as many times as you could. I even took informational interviews for companies that I knew I wasn't going to end up at just because they didn't have something available, but maybe it was up my alley with water resource engineering. And it was great to just be able to sit down with a professional and understand the reality of what I was applying to and just kind of help find your niche a bit more. And at the time I was kind of split. I was thinking about possibly going into the site investigation or remediation side of things. I actually had a job offer at one point for something adjacent to it that I wasn't completely psyched on, or I was going to go for the water resource side, which is where I ended up. But I decided it was time to take a little bit of a break. Right after college, I did a lot of like hiking that summer and just like took some time for myself. And even if you have a job lined up already, I would definitely recommend saying, hey, I'm not going to be at my best, I'm going to be a little burnt out that first month if I start June 1st. And asking for any kind of break to really put you on the right track. Right. So that led me to ending up at Stone, which kind of happened like end of August, maybe the summer after I graduated, maybe into early September. I had stayed in contact with our group leader throughout senior year. I talked about trying to get an internship the summer prior, which I didn't get, but he encouraged me to just stay in contact with him. So maybe a couple of times a year, I'd paint them, see what was going on. I had one, call it like a weed out interview in the spring, make sure we're all on the same page. And then later in the early summer, I had a second interview with them. And to be honest, I got very lucky. I just happened to be in Vermont at the time and was able to have an in-person interview, which I think worked a lot in my favor. But I later heard from my boss, one of the things that really helped me get the job was having very focused interests when I came in the door. We had some college students visiting one day and they were kind of asking similar questions to what we're talking about today. And he's like, oh, well, Jared came in and he like knew he wanted to do stream restoration engineering, and he knew that he just had a very like intentional thought process coming in. And I think I just got that because I sat down with a lot of other interviewers before. I was able to kind of sit in an interview and go, oh, maybe I don't want this job because it just doesn't feel right for X, Y, Z. And just being able to put it into words, I think, really helped me when I was finally sitting in an interview that I really wanted the job for. And something else about Stone is that we have 5 groups. We're water resources. We also have an environmental assessment group. We also do some environmental services like modeling, agricultural and chemical stuff, and we have a whole like geospatial division that does a lot of GIS tools and things of that nature. And I get to work with almost all of them a lot of the time. I have pictured here some work I did with EAR, environmental assessment and remediation, down in Williston on the Commerce Street Superfund site. You want to know about that one? This is a it was, I think, 2 different industrial waste issues, but it ended up with a lot of denable basically in the groundwater, TCE, and some other nasty heavy metals. I think it was originally in the 80s that there was some like unlined lagoon and leach field waste that was getting in there. And there's been a lot of remediation efforts over the years. Stone has been hired by CM Smith to do our part of the remediation. And so I got to be there for a week one summer. And what's going on here is that in this tank is like soybean oil, which is not special by itself, but it's being injected through this manifold here into about like 20 wells at a time or so, but there's maybe like 100 on site. And it's just a home for this like proprietary bacteria that actually eats away at the TCE and some other of the active contamination down there. But it was really cool. Usually a lot of this is like excavation and putting it into a landfill. And this was like a very hands-on active way of remediation. So it was cool for me to get to see this when it's not something that I get to do every day. I had another example there of some cross-group collaboration. It was just with our GDS folks, but just map creation for a forest roads project. We're kind of putting in culverts and things of that nature. So from my perspective, at least, what is water resource engineering at Stone? I do a lot of some stormwater stuff on site and village wastewater. I mostly do the on-site stuff that's like small septic systems for single family dwellings and stuff like that. We have one larger project right now for a village wastewater, which is going to serve maybe 40 or 50 houses and be pumped up to its own leach field. And I've kind of just been involved in that tangentially, just going out last summer with a drill rig to try to find ledges. So we're making sure we're not putting a force main through ledge in too many locations because that gets expensive. We have a little bit of a shoreline erosion program in New Hampshire and Vermont. And what I really love to do, and I've tried to spend a lot of time doing, is the stream restoration, flood restoration, culvert replacement, dam removal side of what we're doing. And we're trying to expand that side of the business as well. That workflow is usually someone going out like myself with total station or an RTK. I saw it looked like your Catskill project you might have had. RTK, is that right? Yeah, I thought I saw one of those there. And it's just going out to try to get topography and stream data so that we can bring it back to create a base map and conceptual design plans. And so that also the modelers have enough information so they may have cross sections. If it's a stream going well upstream, usually try to do like 200 times bank-full width. It's like bank to bank. And at the crossing itself, so if it's a culvert, you might just get it right at the inlet and outlet, so that when they plug it into their models, such as HECRAS, they can understand what's currently going on with the stream and how our conceptual designs may affect it into the future. And so we get feedback from them, and we get feedback from clients and regulators, and continue our design. And then eventually, once it's thumbs up from everyone, it'll go out to bid and construction, and we'll go to the oversight section, which I'll have some examples of coming out, but it's basically just making sure everything goes as planned. And I've got this one. Yeah, that's right. I have some other examples here. So on the far left, this is a gravel wetland that we built at the Camel's Hump Middle School in Richmond. It's basically just a big treatment area for water that's coming off of both 89 and about, I think, half the parcel or so. And we're kind of standing at the downstream end of the gravel wetland looking upstream right now. And these things are big. This is like maybe 100 feet to the other side of the forebay, which then goes to the swale, which goes to 89. And it just acts as storage and treatment for this water before it goes out behind us and then to a swale. This one in the middle here is down in southern Vermont, in I think Searsburg, Vermont. This is one of the first times they were like, "Oh, go crazy! Like just design the stream," which was a lot of fun for me. So I got to go out there with the total station and get all the data that we needed, and then bring it back into CAD and start like working on how this thing's going to look. It's basically a Green Mountain power road that goes up to some wind turbines. But they don't really need this road anymore. There's another access point from the other side. So they said, oh, you can just remove it and restore the stream. So I was just able to get into CAD and kind of match the old stream alignment as best as possible. And yeah, it was just a fun one that I've gotten to see kind of from the beginning to the end. And on the right side here, this is actually only a couple miles away from the culvert on the left. But this is a dam that we're going to remove this summer outside of Wilmington. And it's very embedded into the bedrock, as you might be able to see. And it's got a pretty large sediment, well, not huge, but it's got sediment impoundment above it as well. Initially, we had been planning to do a little bit more like stream work. So we're going to remove the dam after we kind of already regraded the channel a bit, but we've kind of gotten the okay to actually just do like a full release. So we're just going to take the dam out. It's not near anything. It's not at risk of flooding anything. And there's so much bedrock that's kind of going to hold itself in place. So we're not going to need any other kind of buried grade control like we'll see in the next slide to stabilize it. That'll be a fun one because kind of just get to take it down and watch where the stream goes. Okay, so this is maybe a case study that I'll go a little bit more into. I've seen at least a specific project from pretty much its beginning now to its construction. I think just maybe done a few site visits before I started working at Stone. But this is a culvert replacement project up in Morgan, Vermont, which is basically right on the border with Canada. And it's essentially a very steep mountain stream on the upstream portion that's been washing out in floods, most recently in the July 23 and maybe also the 24 floods. And it used to just be this little 18-inch culvert that comes out. And it's a metal culvert at the inlet that was just jammed into a plastic one, maybe 30 feet or so downstream. This is all underground and then eventually popped out maybe like 70 or 80 feet below. It was below like an old barn and a bunch of fill. It was just it was a mess really. Because what we're looking up here is like 6 or 8 feet wide. And when it really was flooding, it was just instantly overtopping the road with sediment and just causing a mess. So we replaced it with an 8-foot span by 5-foot rise box culvert, which I have some photos of in the next slide, and an alluvial fan at the outlet. That was completely new to me when I got this Stone. I'm not sure if there are too many other alluvial fans in Vermont, but this being such a steep mountain stream, it allows the velocity of the water to slow down once it gets to the outlet before it reaches the meadow that I might go show a little bit better in the next slide. That's kind of where those trees are in the background. I pulled up some design plans so we can kind of just see what that looks like. Sorry for anyone in the back who's squinting. The collapse don't matter too much. I'll just try to highlight stuff as we go. But this is the upstream portion here where that picture is taken, and to the outlet of the alluvial fan. And right here is the box culvert. And this was built similarly, but not exactly to how it was designed. We made a couple changes with the contractor once we're in the field. Namely, bedrock was a little bit more of a concern than we realized. Our coring samples that we took to try to find bedrock just missed them every place that we took it, which is sometimes the case. We still got relatively lucky. We only had to raise the box culvert by about 6 inches. And the main thing that changed was this cutoff wall here, which prevents undermining to the culvert as the water is coming in. Instead of being 3 or 4 feet deep, ended up being about 18 inches. But it was on top of bedrock, so it didn't pose too much of a risk. But this culvert basically just has some big wing walls at the entrance and at the exit, and this big alluvial fan in the back, which also, some of the woody additions aren't in this in the next photo, but they have these buried rock grade controls, and that kind of helps keep the stream intact as it is. The 3 upstream we ended up not needing for the same reason that the culvert had to come up because there's a lot of bedrock, so we just didn't need it. And there was nowhere to put it because the stream was going to hold itself in place as is. And then this is the last real slide, just talk through some of the building here. This is a really fun one to go up. I got to go up maybe 3 or 4 times to see this construction. It started with the alluvial fan, which is what we're looking at down here. at the outlet of the culvert, and it's basically just this big maze of root wads and trees and strategic woody additions, which are these kind of logs that are pinned in here with a little rocks in the front. And the first day I showed up, the watershed manager was running around and pointing to the contractor where to put these like, giant 6-7 foot tall like wooden stakes essentially into the ground to pin these giant woody additions in, and it was very fun. There's probably like 50 of these throughout the whole section, and the main channel snaked its way through. And it ends up having a couple functions. One is to help minimize the velocity coming off of this really steep slope, and it also creates habitat for a lot of trout and other things so that they can access upstream riffles and have more breeding habitat. And I'm not a biologist, so I'll stop there because I don't really know what I'm talking about past that, but that helps with that. It was kind of the main channel. We hadn't redirected the water yet when I had taken this. It was just a very rainy day. It was kind of fun to see how the water was starting to snake through there and create some habitat. And I might go back to the other slide to show this actual plan. But you can see on the longitudinal profile here, we got some like baffles in here that helps hold stream bed material in. And you can see it again up here, it's about like 18 inches. That's what all that is spread in the culvert. They worked it out a little bit better than that photo shows. And it basically just acts as like a natural stream bed to the culvert. So it's not just concrete when you're going through there. Yeah, I think that's all I had for you guys, but I'm sure with questions and we can transition to the networking portion.
Does anyone have any questions?
Oh yeah, please. Oh, more questions. Awesome.
I
Nice.
have a question. I was just curious how your like busyness, I guess, adjusts like throughout the year. Like most of the images are taken during like dry seasons or like summertime. Is it mostly designed in like the winter? And how does that transition change? Is it feel like school kind of where you're during the summer?
Well, the summer's
Like
busy.
one ends on like,
But
like
yeah.
internship days versus like homework. I guess.
Yeah, there's like spells that get busier. Like right now, we're in a lot of like we're putting a lot of things out of bid. We're gonna have a really busy summer with like 9 or 10 or 11 things being built, which is then we're gonna be down a couple people, so it could get interesting. But yeah, the construction season can be a little busy, depending how many contracts you have, because you might also be designing things for later in the summer at the same time. I definitely got a little bit of a lull come like February. I'm like, hey, what am I doing right now? But things, kind of just tend to come in a cycle. But yeah, totally, there's a cycle to it. And yeah, summers get busy. There's usually end of year deadlines for fun reasons. So that can get busy in its own regard. But yeah, good time to take vacation like in March. Yeah, Lauren.
What has your mentorship looked like throughout, like starting there, post grad, and then now, and then also like collaboration with other people in the office?
Totally. I wouldn't say I have like one. Well, technically, we do have like a mentorship program at Stone. So I do have like one person who, if I need to, I can go talk to about things related to work or not, and we try to meet like occasionally to do that. I have a good relationship with my manager, so they're definitely a mentor to me, especially with the technical aspects of the job. And then I have a close colleague who's also in EIT, where I work with a lot. But yeah, mentorship, I think in some ways I may not be the best person to talk about, because I sometimes might go, I should be looking for like more mentorships in life, but I don't know. I think it's a good community, and I get to work cross group a lot and kind of find what's nice about Stone is that when you get to work cross group like that, you kind of get a good sample of what the company's like outside of your own realm, so you don't just hear it from the same over and over perspective. But yeah, I could probably find more mentors, to be honest. Good goal. Yeah.
What did the oversight on a project like this look like? And were you ever able to revisit this site?
Yeah. There's a couple people. I went up 3 or 4 times, and my boss went up a few times. The whole process of us going out there, it's like survey, but then it's also like going out with the drill rig, and then once it's in the oversight construction process, we try to be there for the key moments, because frankly, there's usually not enough budget to be there the whole time, because it may be a couple week long endeavor. But so whenever they're putting in box culvert, which came in just like sections, it's good to try to be there, and like at least the first day they're doing that, because they're like making a leveling pad and stuff that you really want to try to get as straight as possible. So it was mostly just trying to be there at like critical moments, that kind of thing. And like when we had to decide, oh, the cutoff wall that we had is too big, like talking to contractors about getting a smaller one, and decisions like that.
What kind of projects does the agricultural chem team work on?
They do a lot of drift studies, which is kind of preventing pesticides from spraying to places you're not supposed to. They work with farmers who are their main clients in the Midwest, and they get to go on fun trips. They get to go to like Brazil and stuff sometimes. I'm always trying to stick on to those trips. They do actually a lot of UAV, like drone studies with a pesticide application. When I first got to Stone, they just come back from South Africa, I think, and they had these like thousands and thousands of mylar cards that had this inert, it wasn't a pesticide, but this inert spray on it, and basically we're just stripping that off and putting it through, not a spectrometer, barometer, I think, to try to understand how much was still left on there. They get a lot of work to like the EPA and stuff as well.
How do you guys like find these projects? Like, do people like hire you guys?
Yeah, that's a great question. Yeah, I'm not on the proposal side of things most of the time, but our partners are at the state level, at the federal level, and private. And so we really have maybe too many places that we go looking for work. But yeah, there are the general terms like an RFP, a request for proposal, that go out through all sorts of agencies and stuff. People reach out directly. They've worked with us in the past. We have relationships with a lot of the like watershed organizations across the state, but it's a lot of hoops. Yeah, and I haven't actually stepped into proposal aspect of it as much yet.
What questions would you recommend to ask? Like if I was having an interview for this type of job, like what do you think would be important?
What questions would I ask? About the company, I kind of skipped over a point I meant to make before about interviewing, is that you should try to look past like base compensation if you can, like if you are just like maybe on Indeed or something and you're like filtering by pay, because it's like, oh, and you're like, oh, that one's like 10K lower, I'm not gonna bother. Like if it's a job that you genuinely like, it might be worth looking in a bit more. Like at Stone, we have some other forms of compensation that a lot of people have, like 401ks or whatever, but we're also employee owned. So we each get like shares of the company, and that's part of your retirement plan. And if you become fully like vested after 6 years, and after you leave, we'll actually get all those shares. But to ask me about like other kinds of compensation they have might be worth it, or researching beforehand, and asking specific questions about how that works could be good. When it comes to maybe the work, I honestly always ask about like the day-to-day work, and just see like, oh, like, so am I going to be doing all CAD, more modeling, like what should I prep or refresh myself on before I started, something like that. Good questions, I guess.
You partially answered the question I was going to ask you with a few answers here, but to wrap it back to the EWB group, I was wondering about the international work, and I can tell the group about positioning themselves for consulting work in the international sphere. Anything you've benefited from here at EWM?
Sure. I definitely talked about it while I was in my interviews. I think at least, I don't know if it was my group leader, but someone in my group had been part of EWB, and it definitely always helps to talk about active club engagement, especially in the international realm. I think it tells people that you're comfortable traveling internationally, and that you at least have some experience with that. some cultural sensitivity, as you folks were talking about before. Yeah, I think it helped a lot. It was one of the first conversations I had with our president when we started. He just like sit down with everyone for a couple minutes to talk, was largely about EWB, because he'd either been in it before or possibly Peace Corps, and we were just talking about like OSHA and stuff like that, and it was a lot of fun. But yeah, I would encourage everyone to talk about your work with EWB. I'm blown away by the work you guys have done. It's really impressive, and I think any interviewer would appreciate that.
We have one last institute thing to do. Thank you for coming. I'm Beverly Muntle, the director of the Water Resources Institute.
Nice to officially meet you.
The Alumni Association, when they heard we were doing the series, dropped off a bag of goodies.
Oh, thank you so much.
We're very happy to have alumni return, and we stuffed the bag also with some institute.
Oh, thank you so much. Nice merch. I love it. Thank you.
You have at least one non-engineering student in the room. There's probably a few listening online too. And glad to have all of you here on this day, and I encourage you to stick around for a little casual networking. We also have someone in the back of the room, Keith Jennings, our director of research, that some of you engineers might want to interact with. Sam Kohler over there just finished her master's degree at the University of Maryland, developing a mesonet project there, meteorological monitoring. So a few people hanging around here you might want to interact with too. All right.
Thanks so much.
And pizza's on its way, I just got the alert.
If there's any engineers without borders related questions as well, directed to either Sienna, Garrett, or I. Yeah, thanks for coming, everyone.